Well, cool. So, as you heard, I'm Jan de Vries, Cloud Solutions Architect, working at 4.net consulting company. And today I'm going to talk about how you should be designing your solutions, be it a monolith, preferably, or a microservice solution. Because microservices are very cool, but also very hard to, well, maintain, design, and implement. So, first of all, who of you all works at Amazon, Google, Spotify, Netflix? I don't see a lot of hands. Zero. So, most of you all, or I'm guessing most of you all work in a rather small to medium-sized company with maybe 50 devs if you're quite big. So, how big are your teams? Well, most of the times less as 50 people. And do you actually need to do microservices? Because what this enables you to do is have a lot of different technology stacks, different solution designs, different software designs in your services, which is cool. But if you're only working with like 10 devs in your shop, well, do you actually want to maintain all of this technical, well, depth, all of these technologies? Most of the time you don't, because you're probably the guy or the girl who has to maintain like a dozen services if you're going microservices. And you don't want one service to be PHP, one other C Sharp, and one other, well, let's say Python, because then you have to be an expert in all of these areas. So why would you go microservices? Well, for scalability, of course. But does it actually scale well? Well, if you're doing it properly, it can scale well, but that's not what I've seen in reality, because a lot of microservices solutions I saw the past couple of years are, well, just designed wrong, and now they have a lot of problems maintaining this kind of stuff. That's why these days I'm trying to tell people, tell customers of mine, well, first just build a monolith, because a monolith is, well, stable. It stands the test of time. Uh, I've seen monoliths dating from back in the 80s to now, which are still maintained, and well, they're maintained, and it's might not be a great design, and everybody might sick when they have to do something in it, but they're still working. Compared to a microservice solution, or at least a lot of solutions I've come across with, just one thing has to happen, like a breeze of the wind, and stuff falls down, and well, you have to fix it, and you have to have some proper logging and analysis tools in place in order to find out what is happening. Most of the microservice solutions I've come across with are, well, being refactored all of the time, being redesigned all of the time. So it's cost a lot of money because they're, well, built like a Jenga tower. If you're moving one piece of it, the whole tower of services might fall down, which is a problem. Of course, this can also happen if you design your monolith solution wrong, which we've probably seen all in the past, because most of the monolith solutions I've come across with are also a big piece of, well, spaghetti code. All of the modules and components are interwoven with each other. So if you change one class, there's a ripple effect across a lot of other classes. So what should you be doing? Well, start off with a monolith, because you probably don't need the complexity and the benefits of a microservice solution. And when starting with a monolith, you should be designing it like, well, silos. Each silo does its own little thing. So once you do need a microservice, the scalability of a microservice solution, you can just pick out a silo of functionality, of course, and place it inside a service. You don't have to do a lot for this, and this actually works quite nicely. It's like, well, half a day work. You just create an, well, let's say an API layer for it, and push it to some Azure App Service and be done with it. And now you have a microservice. and a monolith containing a lot of, well, small services in essence. One of the first microservice solutions I came across with a couple of years ago was this. And you all can probably guess this isn't a very good design. It's actually quite evil. Because what you see over here, it's well, what they've done, they had a database with tables, of course. And what they did, well, each table will be a new service because they have functionality in it, or at least a service should be small and should do one thing. Well, this service only reads and writes and updates customers. True. But most of the time when you want to do something with a customer, you also want to know where he or she works and if he or she has any orders and maybe some personal data like the address. So you have to make a lot of calls somewhere where you're orchestrating this. It could be in the retrieval of a customer. So this service is doing a lot of requests for the user. You could also do this in some kind of Angular app, so making a lot of HTTP calls, synchronous, because first you need to know the data from the customer, get the foreign keys, and make a couple of HTTP calls to get the other data. So that's quite wrong, because it takes a lot of time. You introduce a lot of latency. Of course, this could be a viable design if you want to sell performance as a feature. Because you can tell your customer, your stakeholders, well, the system is slow now, but we can improve the speed drastically. Well, the customer says, okay, and then you just start using Entity Framework or whatever ORM you have, and have, well, blazing fast results. So going from seconds of latency to milliseconds. So this is wrong, and this is something I came across with a couple of years ago. So we also did something a couple of years ago where I was involved in, and well, we read some books, some blog materials on how to design microservices, and we read, well, this should be doing one thing and do it well. Okay. But we had some fails in it, and I'm going to show you why we failed at it. Because one of the things we did is we had a couple of microservices talking with a massive database and connecting with it. So as you can see over here, there's a big database and a couple of small microservices doing their own little thing. And that's a big fail, because once the database goes down, well, your services can't do anything anymore because, well, there's no data input anymore. So that's a big fail. So what we did, well, that's actually this. We had one database, and of course every good architecture needs some kind of identity in it. So we had an identity API and some backend services like SharePoint, SAP, Salesforce, and a couple of others, and also a couple of our own, and all talking to one big database. Cool. This works quite nicely also in any cloud environment, and we didn't have a lot of problems. Still don't. Then some vendors approached us saying, hey Jan, we want to connect with your data, and we were smart enough not to let them connect to our APIs, to our internal APIs. So what we did is we created a business-to-business API, so vendors could connect with our public business API, get the view models they needed, do the nice REST requests they wanted. And because we wanted this business API as some kind of a facade layer, we also had some integration API. And this integration API, what it did is retrieve data from all of the, well, internal systems like SharePoint, Salesforce, whatever. This works because now the business API is a really thin, small layer, only doing retrieval and, well, sending commands. And the integration API has all of the dependencies with external systems. And also connecting to the database, of course, because that's where you store data. This works. And being good Boy Scouts as we are, first of all, we noticed vendors were actually quite happy with it. So they were, well, misusing. They were using the business API quite a lot, so did thousands and thousands of requests, more as we anticipated. So what we thought, well, let's build some management around this. So vendor A can only do X requests per day or per minute or per whatever, and vendor B can do something else. So smart as we are, we created a small management API because we didn't want to store this API data in a customer database. So that was our first big win, having a separate database, a small database, only doing one thing for one service. This works. And we were quite happy with it. Still works. And being good Boy Scouts as we are, we also thought, well, let's drink our own champagne. We have this awesome business API, and we want vendors to connect with it, but we're also a vendor of our own, because we also want to, well, do something with customer data. And let's just use this business API and see what happens, if it works. And if it doesn't work, well, we're probably not the only one experiencing problems, so we can just fix it when necessary. So we want to retrieve data from a bank, and banks are quite old-fashioned, or at least in the Netherlands, some of the traditional banks. So we had to retrieve some data from an FTP location. And of course, this data from a bank is, well, not something we want to store in our internal systems. So we had to parse this data to a format we understand, or we want to understand, and then send it to, well, the business API, where it will be processed in our internal systems. So having read something about microservices, we thought, well, that's 3 steps. That sounds like 3 different services. Retrieve the data, parse it, and send it. Of course, we have to store the data in between, because we thought, well, let's not send the data over the line, just store it in a SQL database, because that's easy to use. We have Entity Framework in the .NET space, which is an awesome ORM just to retrieve and store data. It works quite fast and easy to use. So that's what we did, having a shared database again, and sending it throughout the line. So there's, as I mentioned, there's a small problem with this, again, because now we have another shared database, just like the one in the complete backend. But a different problem is all of these APIs are connected with each other. So what happens if the process API is failing? Well, the parse and the retrieval service will also fail, because they're dependent on each other. So the first one is doing a retrieval, sends something, waits for the result, obviously, because why not? And then if the process API has an internal server error or something, well, it just fails down the line. So that's a big problem. So we created a distributed monolith over here. Quite a serious design flaw. But that's not the only thing, because what happens if the integration API is failing? Everything will fail down the line also, because they're all dependent on each other. So this isn't what you should be doing. So we didn't create one small monolith. We created a massive distributed monolith, because all of the services were, well, connected to each other and dependent on each other. So that's bad design. One other problem you have with this is logging. Because I don't know how you all do logging, but most of the time when we do it, is you have a request, you're entering your controller, your entry point, and you do an starting executing or start executing whatever, and finished executing whatever, or some logging line, in order to see what happens. And you want to correlate all of these logging messages to one request. So the problem is this request, because what we have over here is multiple requests, because every service has a new request coming in and starts a new logging group. So what does this look like in the logging database? Well, something like this. We have logging group 1, 2, 3, 4, etc. and some logging messages. but there's no way to correlate logging group 1 with 2 or 3. You can do some fuzzy magic with the date times, but that's, well, fuzzy magic, so you shouldn't be doing this because it's no hard data. So some of you guys, or some of you all might say, well, I've solved this by adding a correlation ID to the request and sending it down the line, which works, obviously, but it's not something I would recommend. Using a correlation ID for this is actually a hack in your design, because it means your design is suboptimal, your design is wrong, because you need to add some technical data to your requests which have nothing to do with customer requests, with customer, data. So because you have a wrong design, you have to add technical fields to your requests, which is insane, in my opinion. So don't do this, just design your solution properly. So you should, well, like I mentioned, segregate every action per functional domain. This way you can just have one logging group and do all of the stuff in it and be done with it. So logging is easier. What do I mean with this? Well, when you want to retrieve a customer, you're starting the get customer command or a get customer query and do all of the retrieval inside this one big method. Well, I'm not saying you should be writing one big method, but at least do everything in via this entry point and don't call any other services. Just do everything in one request and return the client. So you don't have any dependencies anymore to other systems. You can just do what you want, what the customer wants, or what the stakeholder wants, and be done with it, which solves the logging aspect. So that's something like this for a design. So I have an invoices service, or at least an invoices module, component, whatever language or framework you're using, purchasers and vendors, and whatever other design boundary functional domain you have, and do everything which has something to do with invoices in the invoices component, everything with purchases in the purchases, etc. And of course, I know not everything can be stored inside one big silo, so information has to be shared between those services. Because sometimes you want to know which vendor had an invoice sent to them. So you want to send data via some kind of eventing mechanism. Don't let the invoices service talk to the vendor service or component or whatever, because now you have a dependency between all of them, which means it will break eventually. So use a messaging bus or whatever you have. So if you're doing microservices in the Azure space, you could be using event grid, service bus, storage queues, whatever. If you're using this in a monolith, there are tons and tons of queuing mechanisms to do this all in memory, which even persist to disk or whatever if you need to. So you can do this in a monolith solution inside one big executable also. It's not it's not solely for Azure or cloud solutions. So you can do this everywhere. A big benefit of having such a design is every service, every component is decoupled from each other, which means you can introduce different technologies even in a monolith solution. So it might make sense to have all of the vendor data inside some Elasticsearch database. I don't know why you would want to have this, but it might make sense in your scenario. It might make sense to have all of the purchases data inside a Cosmos DB, inside the document store. Well, I can relate to this. And the invoices to a relational database. Okay, you're used to using a SQL database. Let's just continue using it. So this might make sense. I'm not saying you should be doing this, because I like to stay, well, in one technology stack, especially if you're using, well, if you're in a small team, like 50 minus people. So you have to maintain all of the stuff. So why introduce a lot of dependencies to different technology stacks? That doesn't make sense, like I mentioned a couple of slides earlier. You probably want to stick with one technology stack, like, well, for my case, .NET, and using a single database system technology, like SQL Azure or Cosmos DB or whatever, and stick with it throughout your overall design, unless you actually need the capabilities of a different technology stack. But that should be an exception and not because it's cool. Only if it makes sense in your design. So what does this give us? Well, a lot of duplication. Because if no service is dependent on each other, you probably need to write, well, a repository layer or a data access layer multiple times. You probably need to write, the controller logic, authentication logic multiple times. And that's true. And that's a pain. I know. But it's actually better as sharing all of the code. Because if you're sharing all of the code with each other via some base classes or whatever interwoven thing you have, you also have the problem, if you change one thing, it might have an effect on, well, multiple services, multiple components. And you might not be able to oversee all of these effects. So you will be introducing bugs later on. Of course, if there's a bug in some duplicated code throughout 50 services or 50 components, you have to fix this bug 50 times. And that's a pain also. So you should find some balance in the sharing of code and the not sharing of code. Of course, if you have some tax calculations, like you have a total amount on your invoice and you need to, or purchase order, and you need to calculate some tax, it might be a wise thing to, well, have this bundled inside a package and share it across those services, because it's well, true duplicated code if you do this multiple times. So if you have true duplication, stuff which should change all of the time between all of your components, you should be sharing it, like tax rules. Those things share, well, across all of your systems. So then you can use packages. But if you have some, well, let's say getting an identifier of a user and doing some Mr. or Mrs. Logic on it, well, you can't duplicate all of this stuff because you might want to change this later on for a vendor, but maybe not for a customer. So it's not true duplication, it's just duplication, which doesn't change at the same time across all of the systems. So duplication isn't a bad thing per se. And what does this enable us? Well, get stuff done. Because that's what we're hired for to do. Get stuff done for our customers, for our stakeholders, for our product owners. They have a problem, or at least they think they have a problem, and they want this solved. And we can spend months and months and months on designing a system and reusing services and components and whatever. But if you have just an isolated service or component, you can just focus on getting the task done and be done with it, ship it. So a feature can be shipped, well, directly, and because you don't have any dependencies on other systems, you know for a fact nothing will break. So if something needs to happen in an invoicing service, I can just fix it over here or add it or whatever needs to happen and ship it, the moment I commit it to source control, and know for a fact nothing in my system will break. Well, maybe the invoicing service, because I've just maybe introduced a new bug to it or some performance problems. But if this happens, I can just fix it right away and ship it again, version 2, version 3. So this way I can ship thousands and thousands of deployments per day without affecting the complete system, which is awesome. By leveraging this, we do like, I guess, I'm just going to round it, like 1200 deployments per day. Every commit to the master branch gets pushed directly to production, and whenever something is failing, we know it, we fix the bug, and we ship it again. Automatically, of course. So that's awesome, because we know if something is failing, well, we just relax, sit back. Oh, there's the bug. We have some logging in place because the logging group is the same, and ship it. Easy. What does this also enable you to do? Well, extend the system. I'm an architect, so I use Visio a lot. So this is my main tool during the day. So and every talk should have some Visio diagram. So I have an invoices, purchases, and vendors. The same with the silos, and doing stuff with the message bus in Azure. And now the product owner came to me, hey Jan, we're missing something. We're missing some customer data inside this design, because people can do invoicing, can do purchases, can do vendor stuff, but we haven't got customers in our system, which is a problem, because now, well, we can't create invoices for people, which, well, figures. But it wasn't in the original spec, of course. So what we did with this is just add a new block, or at least what I did, is add a new block, doing adding some icons to it, and telling the developers, well, create it, a customer service, and well, fix it. And by not having any shared code, and by not having any dependencies on different systems, the development team can just implement whatever the product owner, whatever the customer needs in a couple of hours, and ship it to production and see what happens. So having a minimal viable product is, well, easy to do. Of course, a lot of steps are involved by doing this, but if you have such a design, it's easy to extend, because all of the communication between services is going via this message bus. And if you need to extend your system, you can just create a new service, connect to the message bus, add a new subscription to your topic perhaps, and start running the service. And that's all there is to it. So this way we were able to, well, extend our system quite rapidly without, well, failing, having failed stuff in the other services. But coming up with such a design is quite hard, and that's why, well, I'm not the only architect on this team. We have to think together and well, come up with a design which is extensible later on. And well, we take our time for this because we want to do this right. And of course, things can change over time, and we can make changes whenever necessary. But this design part is hard, because if you're doing it wrong, you'll just create a distributed monolith, which is, well, more of a pain. But once the design phase is done, implementation is easy. Just like the MCU, somewhere over here, someone came up with a proper design for all of the movies in the MCU, and come up with, well, how should the story go? How do we work to the end game? So they came up with 21 movies, 22, something like this. That's the design part. That's quite hard to do, because that takes a lot of effort, because you have to plan for, well, 10 plus years in advance. But actually creating all of those movies, all of those services, all of those components should be easy, because the designing phase is done. You know what needs to happen, so you can just create the movie and be done with it. Same goes for the services. What does this give us? Well, easier deployments. As I mentioned, we can just ship a new service in a matter of minutes. and be done with it. Having no effect on the total solution, just new services. At the moment we have like 75, 80 services doing their own little thing. And we add new services on a monthly basis. Because it's easy to do. The only thing we have to do is create a new deployment step in Azure DevOps and point it to the correct solution, and then it's done. Then our product owner can use this new functionality. What does this also give us? Well, better logging and monitoring. Like I mentioned, you have a real logging group. A request comes in, I'm doing all of the stuff, and the request ends. And everything which has happened in between is put inside one logging group, one separate functional domain, which is awesome for logging. Also monitoring. If the customer service is down for some reason, I get a red blinky light on the dashboard, customer service is down. Okay, no problem. I just add it to the status page of our solution. Customer functionality is down. But people can still create invoices, purchases, log in, do all of the stuff. Just can't connect or can't do anything with customers. Not a big problem. We can take our time fixing it because customers can still use our product. Still, I envy pragmatism in our solutions, because coming up with a perfect solution, as I mentioned, it is hard, and most of the time the perfect solution takes too much time to implement or to refactor your current solution. So a pragmatic approach is preferable. I'd rather have a team coming up with a suboptimal solution and which can deliver today or tomorrow, as a team creating the perfect solution and shipping it 3 months from now. Because the pragmatic team, I get business value this week. For the perfect team, it will take 3 months for them to ship it, and then we'll just have to see if this effort has some kind of return of investment. So, of course, the suboptimal, the pragmatic approach might not be the best technical, but we can just see, and if this new feature actually hits off, we can just redesign this new service, this service, to make it better, if we need to. It might be the product owner came up with some feature and no one actually uses it, so why perfect it? Because it will only take time and we will not get our money back, so it's wasted. Some other customer or some other guy I spoke with also had this design, and they were having like 400 services, and 300 of them needed to have some customer data. So 300 services subscribed to this customer data event, customer data objects which were sent to the messaging bus, and store all of this customer data in their own little database, which is fine, which is actually a great solution, but it felt a bit icky, it felt a bit dirty having this customer data replicated across all of those 300 services. And while I agree with it, I don't think I would find it a problem, but they did. So what they came up with is having one big massive customer database. Every service, all of those 300 services had a dependency on it, but not on the actual tables. What they did is created 300 different views in this database, and each view was named accordingly to the name of the service who was subscribed to it, who was dependent on it. So while it's not the best solution from a technical perspective, I get where they're coming from, and so they went with a more pragmatic solution, having one database where they can just update data whenever necessary, and all of the 300 different services get this data immediately. So there's of course a dependency problem on this, because if this database goes down, 300 services don't have well, customer data anymore, which could be a problem. But it's a trade-off. And of course, they did had some stuff in place to make sure this didn't happen, like replication and read duplicates and stuff like this. But still, it's something to consider when you have a perfect design and you can go back to a more pragmatic approach. So that's it for today. You can obviously reach me on any of, well, via email, Twitter, on my blog, or at GitHub. I'll also be in the Ask Me Anything corner today for questions. So if you have some questions on microservices, Azure, whatever, feel free to ask me something. And have a great day. I don't know if there are any questions so far.